Hi, everyone. So we have Desmond Ho from Kyber Network. He's the software developer there, and he will be talking about how to build on Kyber Network. And this session is more focused towards the developers.
Yeah. Hi everyone. My name is Desmond, and I'm a software developer at Kyber Network. So I'll be going through the development over workflow that we kind of use at Kyber, and I feel hopefully these tips that I give you will really help you in terms of the smart contract development and also when you're building your debt. Right. So I have two agendas for today. Let me just present. Right. So I will cover two main topics. Number one, the setup and dependencies that are out there that you can use. And second of all, I will give some solidity tips that I picked up over the years. So a little bit about myself. I've been with Kyber since late 2017 as an intern. And then that was my last, that was during my final semester at a National University of Singapore. And then I converted full-time ever since. So I've been with the company for about 3 years already. And I've seen how the space evolve and all, right? So it's been a very rewarding experience, I would say. Right. So just quickly, I'm just going to dive right in, setup and dependencies. Right. So how does a debt look like, right? So as a user, there are, I would say, two kinds of users. One is the most your average users. They would require a website. They would go to a website, right? And that's where your debt is, right? Where you have a nice interface for them to interact with your smart contract, right? So the website, you kind of encode it. They would press some buttons, and those buttons would kind of encode function calls that you'll be and they are encoded using the Web3 libraries like Web3 or Web3.js or Ethers. And then these encoded data is sent to a node provider such as Infura, Alchemy, or your very own node if you're running it, right? So of course, and then for the more advanced users, they would probably interact with the smart contract directly. And if they do that, they would use, for example, say Etherscan, or maybe they would use their own scripts that they write, and then they would plug in relevant libraries to use. So first of all, right, to get started, right, when you're building, you probably are building on a testnet. So these are some of the public testnets that you can use, right? So we have Robston, Rinkeby, Coven, and Goerli, right? So first of all, you want to get your hands on some ETH, testnet ETH, right? If you're going to test on the public testnet, right? So for all networks, you can use one that's by MetaMask. My crypto, this one's just very new. I think they announced it last week or something. So you can go there. Then there's Robston, Rinkeby, Coven, and Goerli. I would say actually all networks are pretty fine. I wouldn't really give a preference to any. So it's really up to you to just try and use. Of course, some faucets will offer more ETH than others. Yeah. So you can go ahead and just take note of that. Right. So once you have some ETH, right, maybe you're questioning whether there are any token faucets out there. So that's where Kyber comes in, right? We have a nice UI for Robston network. Unfortunately, it's only on Robston. We have not enabled it for the other networks yet. We have not supported other networks. But you can, if you are building on Robston, then you can go to Robston.Kyber network, and then you can exchange your ETH for some testnet DAI, for example, right? But in any case, you can interact directly with a smart contract. So if you go to our developer portal at developer.kyber.network, you want to interact with our proxy contract where you can perform the trades. So there are a few very simple functions for you to just do that trade itself. You can swap the Ether to token, token to ETH, and token to token. And of course, if you're swapping from tokens, you would definitely need to give the ERC20 token allowance first before you call the functions. So I wouldn't dwell too much into this because all these are available at our developer portal. How to integrate us? Just head over to our developer portal to read more about our docs, our very comprehensive docs. Alternatively, you can also join our Discord and Telegram chats. We are more than ready to help you and support you. Right. So we also have this upcoming product that we are launching really soon. Coming soon, yeah. It's what we call our dynamic automated market maker, or DAMM, right? So it is built off Uniswap's model, right? And I would say there are two main features or main modifications that we made. The first of all is this feature called dynamic fees, right? So currently, Uniswap charges a fixed fee of 0.3%. But for us, in this model, what we do is we kind of like adjust it based on volume as an indicator, right? So when volume is high, then we would charge the smart contract will calculate and notice that the volume traded is high, and then it would increase the fees, and vice versa, right? If say some pairs are not generating as much volume, then the fees will be reduced to encourage people to trade. So that's the first thing about dynamic fees, right? The second of all is what we call the programmable curves. What really this is about is what we call the introduction of an amplification factor, right? So all it does is really to kind of use your real balances, boost it, and then you have like these virtual balances, right? And the virtual balances kind of help to offer better slippage rates as opposed to using real balances. But of course, that comes at a trade-off, right? So anyway, if you want to find out more, please just go to this link, files. You can you read more and just Google like the Kyber DAMM light paper, and I'm pretty sure you'll find the same similar link. Okay, so let's just dive right in quickly. What are the useful packages and libraries that are out there? So first of all, I'm going to talk about smart contract development, right? There are three main like websites that I recommend, three main like packages. Number one, Remix. So Remix offers very quick, like you want quick iterations, right? If you want to test out like something that you are unsure of, like maybe there was like a certain feature that you want to test, but you're not really sure how to what's the syntax like, and you want to just really quickly interact with it, build it, then I recommend Remix, right? So you can like code up a smart contract in like say 5-10 minutes, and you just wanted to test like maybe this certain part of your code, whether or not this like concept works, right? So maybe yeah, I can't really think of a specific example here, but Remix really helps to fine-tune certain, it's a little bit more fine-tuning in my opinion, but it's also a great introductory tool if you are like just wanting to get hands dirty on Solidity, right? Second of all, Truffle. Truffle has been around for a very long time already, since like 3-4 years ago. Hardhat is quite recent. I think they came out like late 2019 or early 2020. And then they are my de facto package library to use at the moment. So I'll give you a few reasons why, right? First of all, when it comes to contract compilation and testing, it's separated. If you're using Truffle, right, they tend to require the compilation and then you're able to run a test. But with Hardhat, they split it. Second of all is this like lovely, wonderful feature called console logging. So previously, when like before this feature, right, debugging contracts was such a pain. You really had to like add in like revert statements like in the code, and then you just keep running of compile and then run your tests, and then you figure out exactly like you try to guess which line of code exactly where the error was, right? Sometimes it's a logic bug, right? And those are like the worst. So because it's not easily spotted, it's not picked up by the compiler, right? So anyway, Hardhat has that. Second, the other feature is multiple version compilations. So let's say you're working with, you're trying to build on top of different projects, right? So maybe like Aave or Synthetics. One uses Sol 5, another uses like say Sol 6, right? So then if you're using Truffle, they only tend to only enable compilation of a single version, right? So it kind of doesn't have enable that it doesn't really allow you to kind of like interact, build upon both contracts, both types of products at the same time, right? So this is where Hardhat really comes in handy, where they offer you to compile different versions of, they allow to compile Solidity files that were written in multiple SOSI versions, right? So that's another feature, a great feature. Third one, I would say, fourth one, sorry, is the plugin, is the white plugin ecosystem that they have, right? So they have like Hardhat, for example, Hardhat deploy helps you to handle deployments. Second of all, it's like the Etherscan Hardhat plugin that helps you to automatically verify contracts on Etherscan. And then hard hat React, allows you to quickly like plug your smart contracts into React.js dev, right? And of course, they also have mainnet forking, right? So if you are lazy, you don't really want to like deploy another product, like say maybe Avi's whole infrastructure from scratch, right? So mainnet forking, you can do that as well, and console logging. Yeah, I cannot stress console logging enough. Yeah. Right. So that's smart contract development. Second of all is the Web3 libraries that are out there. So there tends to be two major ones. One is Web3.js or Python. Second of the other one is Ethers. My recommendation is Ethers. I'll give you reasons as well. So first of all is multiple node connections, right? So let's say you want to connect not just to an Infura node, you have your own node, you can do that. And then you can have like, say if you're doing it on, if you're deploying a contract or you are like running a transaction on mainnet, right? Then they have this like quorum feature where the data written by like specified, let's say you have like you're connected to 3 node providers, right? You can specify a quorum of 2. So meaning like 2 out of 3 must return like the same like kind of result, right? So they have that, but Web3 doesn't. Web3.js or Python doesn't. Second of all, they have better ENS support. And they also have dry run transactions, right? So what this allows you to do is to kind of like test out a transaction without really having to send it out, send it directly onto mainnet and therefore wasting gas, right? So you have to really have to read more into their documentation in order to know more about these features. And of course, they have some very nice constants that they specifically define in the library that you can just easily import. Right. So now moving on to node providers, right? So over here, there's a few, but of course, my recommendation here is Infura because it's free. Yeah, that's the only reason why. Yeah. So that's that. Lastly, website frameworks. Most people that I ask, they tend to develop in either React or Vue.js, right? I recommend React because they have nicer components out there already. So for example, Rainbow is one, developed by Consensus. Over here, I will just quickly show you the plugins that they have, right? So for example, let's say they have like very nice like components that you can just directly import, right? So you want like icons to represent Ethereum addresses, avatars, boxes, buttons, cards to display ETH, right? Addresses, flashcards. Yeah, so they have like very nice support for Ethereum stuff already, right? Do just check out their website and you'll be able to learn more. And of course, okay, right. So the next one is another component that I recommend is the Web3 model. So over here, right, I think if you've interacted with dApps long enough, you'll be able to see like this like very simple like screen that they have support for multiple wallet providers already, right? So like Taurus or Matic, Wallet Connect and stuff, right? So just it's on GitHub, and you can just quickly visit that website as well. So these are only like React components only. I couldn't really find Vue similar ones for Vue, and therefore I recommend React. Right. So the overall debt structure looks like this, right? So you build a website based on React, and then you use Ethers.js to kind of like plug the function calls into buttons, right? And then you have your Infura node that you plug into as well to send the data over, and then you use a hard hat for contract development, right? So this is like my recommended stack. Yeah. Great. So that's the first part. Second part of the agenda is Solidity tips, right? So over here, let's say you are like a total beginner on Solidity, right? You have like zero knowledge on Solidity. So there are many like websites and you can visit, to learn more, to read more. But my recommendation is just to get your hands quick and dirty. And one way to do that is through Crypto Zombies, right? So I'll just quickly show you here the website, right? So you can run through the courses. They are really very interactive, and if you like start, and then they have many parts as well. So just run through them, and it should give you a better grasp of how the syntax works, and the different various concepts that Solidity has. Yeah, so that's one website. The other one that I do recommend is, the other two, sorry, is to really learn about past attacks that have happened before. And then you can do that on two websites, right? First is Ethernaut. Second of all is this like Capture the Ether, right? So, for Capture the Ether, they have like various challenges here. And then, you can try to be on the leaderboard, right? So each challenge that you see here, right, they reward you in some points, right? And then, you try to aim to be on the leaderboard, right? So of course, I believe like 11,600 is like the max you can go, where you completed all the challenges, right? So try your best to get there. As you can see, I'm only on like 7,000. Yeah. Haven't been working on it. Of course, I think couldn't figure out some. Anyways, versioning, right? So there are many SOC versions out there, right? 5, 4, 5, 6, 7, 8. Which one to use? I would say I would recommend not using SOL 8, right? Why? Because even though it's the latest, and it has a very nice feature of a native integer over and underflow checks. That means you don't really have to import like a SafeMath library, right? But the problem is that your existing tools, like Cardhead, for example, right? Or like the plugins that I recommended, they lack the support they lack SOL 8 support, for example. I think now it's slightly better because there's already like a few SOL 8 versions out there. So I think it's pretty fast for this dev tooling to update as well. But of course, you never know. I do recommend using more like stable versions, like maybe SOL 7. Yeah, of course, yeah. Or SOL 6. Yeah. So that's for versioning. Great. So with regards to like smart contract helpers, right, or like things that you don't really need to code, so that you don't have to code from scratch, right? I recommend OpenZeppelin, right? They have like ERC token standard implementations. So if you're looking to implement ERC 20, 721, 1155, they have those templates already there. If you're using older versions, then you will need SafeMath. They allow for permission roles, right? So let's say you only want like you want to create like certain roles. So you have like certain roles, like say admin, then admin can only call like certain functions, or like you have an owner, right? Like ownable, right? So only owner can call like certain functions. Yeah, so they allow for that. And they allow you to also create your own permission roles. So, and then of course you just import that, declare that modifier for your functions, so that only those like permission roles are able to call those functions, right? So there are a few more like on-chain signature verification. Do check them out. Yeah. Right. So what are the like common problems that I face, right, as a Solidity developer, right? So there's this like very, very annoying headache that I get when it comes to development. It's called stack too deep, right? So you can see there was this survey done, right, out of the 232 replies, from which like 150 contain usable data. Number 5 is stack too deep, right? So what exactly is this stack to deep problem, right? You can't have more than 16 local variables in your function, right? Yeah, I mean, it's because of how the stack works, right? Because each in the contract, right, your storage, right, it's defined in contiguous 32 byte slots, right? So then if you have like too many, then it will run into an error. And in this case, it's 16, right? So there are a few solutions that you can use to get around this problem, right? So let's say you define like the first of all is to use structures, right? So you can declare like structures. Let's say you have like many variables here, right? So this like one example, right? You declare like say a cycle root, and then content hash, timestamp, block number, and then you kind of like repeat that, but for like a different. So in this case, like this is like the current cycle data, and then like you have a pending cycle data that's like incoming. So then maybe just it's better to maybe just define a structure, and then you define like the current Merkle data and pending Merkle data, right? So using structures will help to remove this problem in a way, right? But of course, this is just one solution. Another is just breaking up your code a little bit. So you define sub functions, right? So let's say you have like do some stuff, right? A, B, C, D, you do the sum, right? And then maybe like this becomes a problem, right? Maybe you have like A, B, C, D, E, F, G, H, I, right? And then it's too long, too many variables declared. So what you can do is you break it up into smaller subfunctions, yeah, like this. And last of all is what is called block scoping. So if you look at the example here, right, you can see you define, for example, unsigned integer x equals to 1, right? So then you want to declare like more variables, but then they're only used for like a certain part of the function, right? So let's say x equal to, then you declare like y and z. You can do some stuff with y and z, and then maybe you continue to modify x with y and z, but then you realize you don't need y and z anymore after outside of this scope, right? So then once you exit this scope, you will realize that y and z is undefined, but x will still be the modified value that you have done inside this block of code, right? So you can see here that because here you modify the x to be 2, so over here when you return x, x will be 2, right? So that's the first problem. The second problem that as developers I tend to face is contract size, code contract size, right? It cannot exceed this very magical number, 24,576. The reason being why, it's because it's in hex, it's 6,000, or in other words, 2 to the power 14 plus 2 to the power 13, right? And this has been implemented since the spurious dragon hard fork. Yeah, it's there already, right? So this is actually EIP 170. You can like Google EIP 170 to find out the rationale behind this implementation, this proposal. Yeah. So what are some solutions you can use? First of all, is what you can do is to limit the function and variable scope, right? So if you realize you keep defining like public functions, but you find that like for example this function, it's only called, you don't call it internally in the contract itself, right? And you want it to be called externally, like through your by users, by other smart contracts. Then in that case, it's better to just declare it to be external, right? So then it will help to reduce your contract size there, right? And same thing if you have like if you're only gonna use that variable internally in the contract itself, then just define it to be internal. That would help as well. Second thing that you can do is to shorten your error messages. So this happens to be a very long message, right? Because like I said, like each storage slot happens to be in contiguous like 32, stored in like 32 bytes, right? So then you can try to limit your error message to 32 bytes, right? So yeah, just try to keep your error messages short, but hopefully it's still understandable. So then you know like what the error is. Yeah. Third thing to do is you can turn on optimization, right? So this is a setting that you can do on Remix as well, and on Hardhat, yeah, and Truffle. Just make sure it's enabled, and then you have runs, right? So runs, if you realize if you turn it on and then you leave it at 200, you realize that your contract size is too big. What you can do is to try to reduce it bit by bit until the max, the like lowest limit you can go is 1. Yeah, such that if you don't turn it on, your bytecode size is larger than if you had turned it on, right? But if you were to increase this SOC runs number, right, then it will increase your bytecode size again. Yeah, so it's kind of like a fine balance there. Yeah, but in any case, you do want to turn it on. Yeah. Last of all is, okay, I think that's it I have for the when it comes to the contract size problem, right? So a few tips on optimizations. Like I said, 32 bytes storage slots, right? So over here, because it's contiguous, right? Over here, let's say you define say like a vote structure to be this way, right? U24L8, 256, and Boolean. Boolean takes up 8 bits, right? So over here, you are taking out 1 and then 2 because this needs to go into the next storage slot, takes up the second storage slot, and then you tell another one. So this it takes up a total of 3 storage slots here, right? But if you were to shift it up instead, right? So this this will take up 248 bits. This takes up 8 bits. So these two together takes up 1 storage slot, and then your other variable here will take up another one. So you went from 3 storage slots to 2, right? So that really helps to optimize your contract. Yeah. And second of all, increase OC runs, right? So what this does is to help reduce gas costs when you make function calls, but it does not reduce the contract bytecode size on deployment, right? In fact, it will increase it. So like I said, it's a fine balance to here at play here. Yeah. Right. So finally, some debugging tools. If once you deploy it on testnet, then you're testing it out, you have this very, very annoying error. And I'm pretty sure some of you have already experienced it if you use like Uniswap, right? You see this transaction error, exception thrown in contract code, right? So what can you do? On testnet, you can confirm it. What you can do is actually to reduce the gas limit. So to maybe like say, it depends on your function, how much gas it usually takes for it to be successfully executed. But I would say maybe a ballpark of like 500,000 to 1 million. And then you just send it, even though it shows the alert, right? So you just confirm it. What you can do is 2 things, right? So one, if you use Etherscan, it will help you to tell you what the error is, right? So this is picked up from the required statement, right? Because you define an error message, Etherscan will help to display that error message, right? So for example, this is like a 0 source amount, right? So you kind of like know exactly which line of code this error happened. And then from there, you can try to imply and deduce what went wrong. Second of all, there's a better tool, and it's called Tenderly. So over here, right, they tell you exactly which line is wrong. I can show you an example here, right? So over here is there is a transaction made, and they are interacting with the Kyber network proxy contract, right? So it does the full trace for you, right? And then you can see exactly what went wrong at which line, right? And then there's this like view debugger. So if you go to the debugger here, right, it tells you the state of the contract at that time, right? So like you can see here, these are the call data parameters that were passed in. So you can like run through it, and then you run through your code. So it tells you like what's the input that was taken, what's the output. The two, like this is a subtraction that's happening, right? So this minus this gives you this, right? So you can keep running, and then you will run, then you will find out what exactly went wrong. So I'm just going to step over a few times. Yeah. And then it will tell you why exactly. Yeah, so it gives you the state of the contract. Yeah. At that time. So then you are able to sort of debug better. Okay, so that's with regards to debugging. And finally, some hackathon advice, right? So you have like, I think 9 to 10 days of to build a product. So my recommendation is to, number one, tie down on when you're for the smart contract developers, right? Tie down on the function names and arguments, because those will be called by the front end, right? So the front end developer will know kind of like what functions and arguments to plug into his buttons, right? So try to confirm what those function names are and what those arguments are as soon as possible. Second of all is to scope out your project, right? So try to break it down into modular pieces so that multiple people can work on it, right? So you have your front end, maybe you have your back end, right? And you have your smart contract. So try to scope that out and assign based on the number of people that you have. Finally, just have fun. Really, I think take it as a learning process. If you're a new beginner, just take it to learn how this play with the different tools that I recommended here. And then, it should help you to learn something new, right? And who knows, right? Maybe you get to win a prize like I did. So this was a hackathon that I participated 2 years back, 2019. Yeah, and I came in second runner. Yeah, so that is all that I have for my presentation. So if you have any questions, feel free to ask.
Yeah. Thank you, Desmond. Thanks a lot for that. That was pretty insightful for the developers, I'm sure. Yeah. I had a question, Desmond, because in this hackathon, the developers will be building something, an MVP or a working prototype in a very short span of time. and we do get developers who don't have any blockchain experience in the past. So
Yes.
this hackathon will last for 10 days. I was wondering if you have any advice for them where to start. Should they just start with Solidity because, or should they just learn the languages that they already know?
Right. So for smart contract developers, I think, okay, so I talk a lot about Solidity because there's a lot more, the ecosystem is stronger there, right? So, but that's like if you're very familiar with JavaScript. There's an alternative. If let's say you are very familiar with Python, there's Viper, VYPER, right? So that's like another smart contract programming language that you can learn if you are very familiar with Python because the syntax is very similar as well. So given the fact that you only have like 10 days, honestly, I feel that you can pick up Solidity in 1 to 2 days, like really fast. So just try out like the crypto zombies, try out the capture the ether, just to get a rough idea of how the syntax works. And then from there, you should be able to get your hands dirty already. And of course, if you run into problems, there's always Stack Overflow. Yeah, that you can, if you run into a certain error, just copy paste that error message into Google, and I'm pretty sure someone has encountered that problem before. Yeah.
All right, all right. Getting this question from Marino. I'm sorry if I'm pronouncing the name wrong. Which network would you recommend to start trying our first contracts? JavaScript network, Ganche, some Ethereum testnet?
Okay, so let's say you're using Hardhat, right? You can spin up your own local instance of the network. It depends on, okay, I guess it depends on whether you're building on top of company's product. Say maybe Aave, right? You want to build something on top of their lending services, right? So then, like I mentioned, Hardhat has a very nice feature of minute forking. So what minute forking does is it kind of replicates the whole like EVM state, right? Into, and it kind of like pulls that data down into your own like machine. So then it allows you to test against like production contracts on your own like machine. Yeah. So that's one alternate. That's one thing that you can do. Second, of course, like I mentioned, public testnets. So you just go ahead, deploy your contract onto, say, Robston, Rinkleby, Coven. I think depends on what you're building on top. Then Google whether they have support for on that network, and then that should help to speed up the process.
All right, perfect. Um, if you could just briefly tell us, like, what are the plans of Kyber Network going forward? What are you guys developing? If we should keep an eye out on something.
Yeah, sure. So we announced recently about Kyber 3.0, where we are fragmenting like this. We have our current liquidity protocols, right? So we're kind of splitting it up because we realized that there are better aggregators. We used to be like the single endpoint for takers, right? So let's say we pulled from different sources like Uniswap. We integrated Uniswap, and I think what's the other one? Gnosis, that had very good liquidity. And we have our own system of a automated market makers, which we term to be the automated price reserves. And then finally, we have our another type of reserve called the Fed price reserve that's being operated by professional market makers, right? So we have this like algorithm that runs through all these different types of systems to find the best price, right? And then we get the user to trade against that. So the main problem that we have come across is gas consumption, right? Trades on Kyber is a lot more expensive than you would be doing on SushiSwap or Uniswap, right? So and of course, I think like 1inch, for example, they have integrated us, and so we leave the aggregation to them. And what we're doing is we are just like gonna focus on building all these different segment all these different protocols into their own. So bridge reserves will be its own protocol. The FPR, the professional market maker, will be its own protocol. And finally, this DAMM that I just mentioned, that will be its own thing as well. Yeah. So we are working on all these things, and of course, we do have a new token coming up to support all these efforts, right? So there'll be a token migration that will be happening, and finally, with the new token comes a new governance model as well.
Right.
So we forked Avi's governance infrastructure, and we are using that. We made some modifications to their infrastructure, and we're gonna use it. We're gonna use it for our own.
Yeah, perfect. Yeah. Thanks, Desmond. Thank you for taking out the time. And if developers want to reach out to you, is Twitter the best way to reach out to you? Or
Telegram, please. Yeah.
Telegram? All right.
Yeah. Anyhow, click. Yeah. But
Okay.
you can just join our Telegram
Telegram group, Kyber
Telegram
network.
group or Discord. Yeah. I'll be there, and a few of my colleagues will be there as well.
All right. Perfect. Thanks, Desmond. You have a good
All
day.
right.
Thank you for taking out
Thank
the time.
you. Thank you all. Bye bye.